Okay, students, our new unit is going to deal with trigonometry, and we are going to start off with a little bit of a review, which is using our right triangle trig. You are going to want to have a calculator, and you will want to make sure that your mode, I'm checking mine right now, that your mode is on degrees. We will get to radians, but for now we're going to start with what we know, which is our degrees. Okay, now I did put on here, the slides are in your Schoology folder for Unit 2, and I put in here just an adorable little video. If you need to pass the time, feel free to check out that link. All right. Sorry, I'm flinging past there. We're going into the pit. Here's your learning goal for today. I can solve and interpret a right triangle problem in a given context. So these will be problems that are situations, and you will have the following criteria for success. When you solve a right triangle context problem, you will draw and label an accurate diagram. You're going to identify your unknown quantities. You will set up an equation and you will solve, showing those solving steps, and you're going to answer your question in a complete sentence. So we're going to give you these criteria for success each time so you know exactly what you need in order to be successful. All right, so you have a graphic organizer. This is in your PDF, page 7, or if you've already picked up your packet, again, page 7 is where you'll find this. So we have our function here, or sorry, our angle here, theta, is what we're looking at. And everything will be in the perspective of this angle. So if we think about this angle, the opposite side has to be over here. Now, had we changed this, let's say we used alpha for this angle here, then of course the opposite side is here. So it's all a matter of perspective on which angle you're actually talking about. So in this triangle, we're going to use the alpha down here at the lower right. So this is the opposite side. This would be the side adjacent. And of course, across from the right angle is always our hypotenuse. Okay, adjacent is right next to our angle, and opposite, of course, is across. Okay, so we have our SOHCAHTOA, if you remember this. SOHCAHTOA. And so to help you remember sine, cosine, and tangent, we're using these different ratios. So if we have the sine function, we would say sine like this. Don't say sin or sin. We still pronounce it the same. We still say sine. And if we're saying all of these of theta, let's say, sine is the opposite over the hypotenuse. And that's how we would get sine of an angle. Sine of theta is the opposite over the hypotenuse. We have cosine of an angle. And again, we'll say cos here. We're not going to say cos. We're still going to say cosine of theta. And cosine of theta is adjacent over hypotenuse. That is the ratio. So the cosine of theta is equal, and maybe I should put this here. These are equal to those ratios. And then a third one is tangent of an angle. And so we're going to write tan. Again, we're going to say tangent of theta, and that's opposite over adjacent. We're going to continue to fill in this trigonometry function guide with 3 more functions, but for now we're going to stick with these 3, and we're going to go ahead and get into our word problems. Okay, so a couple of things you need to know before we begin is angle of elevation and angle of depression. So this guy's little eyeball is right here, and he is looking straight out. If we're talking about an angle of elevation from our horizontal line up, that is our angle of elevation. And if he is looking down, so this is when he's looking up at this object here. So if he's looking in this direction, that's your angle. And if he's looking down at an object down here, he is going to be from horizontal, from this right here again, he's looking down, and it's this angle. Students do mix these things up, and we're going to look at this with the word problems, but I want you to take a look at this and maybe draw this a little bit in your notes just so you can try to remember. It's always from the horizontal, and then shift your eyes up to an object or shift your eyes down to an object. Here's another perspective. Again, this man's eye is right here, and he's looking straight out, and then shifts his gaze down to this bug. This is the angle of depression. Now, if I'm this bug, let's say here's my eyeball, I'm looking straight out, and then I'm shifting my eye up to this man. This is my angle of elevation. So we always start from horizontal and then move our eye to the object. That's what creates the angle. From horizontal to the object, that is your angle. Okay, example 1. Get ready for these. I wrote these late at night, so we'll see how this goes. All right, Mrs. Wojcik is terrified of roller coaster. That is a true statement. She is standing on the ground and looking to the tallest part of the American Eagle roller coaster at an angle of elevation of 30 degrees. The American Eagle, located at Six Flags Great America near Chicago, Illinois, has a height of 127 feet. By the way, this is also a wooden roller coaster, which makes it even worse, in my opinion. How far is she standing with a look of dread, probably eating some sort of a snack, away from the American Eagle coaster? Also, Mrs. Wojcik is 5'6", 5 feet 6 inches. Okay, fun fact, not related to solving this problem, is that I went on my first real roller coaster as a senior in high school on a physics field trip. Definitely I was pressured the entire time and terrified, but it was a fun memory. Okay, so let's say that here is the top of this roller coaster, okay? So like you're going up, 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 and then woo, then you're screaming. I start screaming here, get to the top, keep screaming the whole way, okay? So this is, let's say, the height of the roller coaster. Okay, now let's see what we know here. So I am standing, oopsies, that's a little bit crooked. I kind of want to do that again. Okay, so I'm standing over here, and so I'm going to put me right here. Think of me having like a real scary face. Am I allowed to make this bigger to put in my scary face? Let's see. Okay, there I am. Okay, so I'm super, super scared. All right, which is not a lie. That is totally true. And I want to know how far away I am from this highest point. Okay, and we're thinking along the ground. How far along the ground am I standing? Okay, this is 127 feet. So what I'm doing is I'm going back to the problem, sifting through all this nonsense to find out what are the important pieces that I need to draw in here. Okay, now we definitely, we're gonna say this is a right angle. We're looking at a right triangle here. And we have this, and we have an angle of elevation. Now here is a tricky part. Here is my eyeball, right, is here. So here is my horizontal. And so my angle of elevation should really be here. Okay, that's my angle of elevation. So we're gonna have to change our picture a little bit. This said, there's information here that 5 feet 6 inches. So conveniently 5.5 feet. So I'm gonna actually write it as 5.5 feet is my height. So we're gonna say 5.5 feet. And we are gonna actually alter this right triangle. This is obviously not to scale, which is totally fine. Okay, so we don't really wanna deal with the 127 feet. And let me just move this into a different location. This is why we're going to be drawing these pictures, figuring out what the heck is going on here. This is 127 feet the whole way. Now in orange, how would we figure out what this orange part is right here? We would take 127 and subtract my height. So we would get 121.5 feet. Okay. Okay, so that's where we really need to draw this out. And I know some people are like, well, this is silly. I'm not drawing Mrs. Wojcik with a scary face and whatever else. But I would encourage you to do this to get sort of a feeling. And obviously you don't have to have a super involved picture, but you do need to label what the heck is going on. Okay, so I'm going to actually put a couple more things in here. So I'm going to say that this is the top of coaster. I'm going to say this is total height of coaster. And this is the height from Mrs. W's eye to coaster. I'm kind of writing all over my triangle. Okay, this is me. And X is going to be the distance from the base of highest point. Whoa, what am I doing here? To Mrs. W. on ground. Okay, so and you can write this differently, but I just want to be clear on what the heck I'm actually solving for, okay? So now that we see this X down here, but I'm actually going to move this X above. Notice this is exactly the same X, okay? So we're trying to find this, which is the same as it was below, but notice we've just changed that one side of the triangle due to my not being actually smashed onto the ground, okay? Which wouldn't make a lot of sense, and it sounds painful. Okay, so we're trying to find this X. What do we know? Now, we know something about an angle. So it says my angle of elevation is 30 degrees. So from the horizontal, I'm looking up. From the horizontal, I'm looking up 30 degrees. Okay, now we need to decide what the heck trig function is going to work for this. So we have our angle, or theta, as we were looking in the other ones. We need to find one of these legs. We do have the opposite. So we want to think what deals with the opposite and the adjacent, and the answer for that is tangent. Tangent of 30 degrees is equal to the opposite, which is 121.5 feet, over x, which we don't know yet. I'm going to go ahead and show what I'm doing here. I'm going to multiply both sides by x to get x tangent 30 degrees equals, these obviously will cancel, 121.5, and then I'm going to divide both sides. I'm just going to change color so you can see the difference here. Dividing by this number, which is tangent of 30 degrees. Obviously, a number divided by itself is just 1, and so we have x is about equal to, and I'm going to go ahead and type this in here, 121.5 divided by, and make sure again you're in degrees, tangent of 30 is going to give me approximately 210.44 feet. Okay, now we are going to answer this in a sentence. So, Mrs. Wojcik is standing approximately 210.44 feet on the ground away from the base of the highest point of the coaster. And why am I adding that detail? Well, I'm not really standing that far away from the base of the coaster because there could be way closer pieces that are lower. I'm really talking about from this highest point. If I dropped a rope down, how was it that distance? And I want to know from the base of that, where am I? Okay, example 2. An eagle, I'm not sure why I had a thing with the eagles, is perched in a tree at a height of 175 feet above a lake. In that lake, Mrs. Wojcik just landed a huge salmon. It is a keeper. If the eagle is looking down at that juicy fish with an angle of depression of 25 degrees, how far will the eagle need to fly to swoop in, there should be and grab dinner? Okay, again, we need to figure out what the heck is going on with this problem. And here's my great tree, and there's some sort of a beautiful lake here. Okay, this is the lake. All right, and then I need to be somewhere in my fancy boat. We'll do brown because that makes sense. Okay, here's my little boat. We'll pretend like it's a little sailboat. And then, of course, me, I don't know why I'm green and the tree is purple, but that's okay. It doesn't really matter. Okay, and I'm holding some little fish, and we'll make this guy orange. So I'm holding this. Oh my gosh, this is a terrible looking fish. Okay, ta-da. Okay, there's my fish. Oh, I really should have a little fishing rod or something, shouldn't I? That looks like I'm gonna beat the fish. Okay, I didn't do that. I'm holding this fish, and I really actually don't like fishing at all. Oh, and then we need our little bird. So, oh my, that's like an upside down bird. I forgot how to draw little birds. It's like an M, right? Yeah, there we go. Okay, so here's my eagle. Okay, here he is. Okay, now let's see what the heck's going on here. The tree is the height of 170 feet above the lake. So I'm going to go ahead, and he's at the top of the tree, we're going to say, because of course we're dealing with perfect world. And we're going to make this 175 feet above the lake. Okay, I just got a salmon. The eagle is looking down at that fish. Okay, so the eagle's eye, straight this way, right? And looking down at the fish. Now, I kind of want to cheat a little bit. And you're like, oh my gosh, you erased that beautiful drawing. I know, that's just terrible. We're going to make it so this fish is right on the water. We're going to do that because then we'll have to deal with a little less of some issues here. So let's say my legs are already in the boat, right? So there's my hands and my head. And then, oh yeah, we got to get that little fishing pole, which is going to look like this. And then here's my fish. So I just landed this fish. Okay, let's say like this, okay? All right, so this eagle is looking straight out and then looks down, angle of depression. That's what this is, angle of depression. So looking down, here is the angle of depression. Students usually are going to make the mistake of putting the angle here, but that doesn't make any sense. We're looking straight out and then shift your eyeball down to the fish. So this is 25 degrees. This is our right angle, and we're going to go ahead and draw this triangle. Okay. 175 feet above the lake. We have an angle. Now, we need an angle inside of this triangle. We know that this is a right angle. Now, that's not all in the triangle, but that's still a right angle. So if we take this, we would get 65 degrees inside because we know that 65 plus 25 is 90 degrees. So now we have 65 degrees, and guess what? We have 25 degrees here. So just bringing back a little geometry information, we have alternate interior angles, and we're looking at these two parallel lines right here. Okay. All right, so our goal is to find what? Okay, here is my goal. X equals the distance eagle has to fly. Eagle will need to fly. Okay, we don't know this, but we don't really care. And we already have the height the eagle is above the lake. So let's go ahead and try to set this up. We have two angles to choose from. Does not matter which angle you use, but we do need to include this hypotenuse. So we're saying we want either sine or cosine. So I am going to go ahead and use, changed my mind. Let's see. No, changed it back again. Let's say the sine of 25 degrees, and that is the opposite over the hypotenuse. Okay, let's go ahead and solve. So I'm going to multiply both sides by x. These are going to, of course, cancel because the number over itself is just 1. We get x sine of 25 degrees is equal to 175. And then I'm just going to keep changing colors to show my steps. We're going to divide by sine of 25 degrees, which is just a number. A number over itself is 1. And so x would be about equal to, let me type this in and see what we get. About equal to 414.0 9, if I round, feet. Now, you're like, well, Mrs. Wojcik, I labeled it. That should be enough. We're still going to answer the question in a sentence. So we're going to say the eagle would need to fly a distance of 414.09, let's say approximately that many feet to feast on the fish. So this seems like a pretty long distance. I don't know. I should look up how far can an eagle fly in one swoop. Going downhill, maybe that's a little bit easier. I don't know. But this would be about how long. And here's another note for you. My family, we used to take the kids and go up north to Wisconsin. My daughter's laughing at me as I'm recording this. And one time we saw an eagle grab a fish, or was flying with the fish, and we're like, whoa, and then dropped it. I don't know if it saw something better or what happened. And then this fish landed on our like driveway area, and oh my gosh, it had big giant holes in it from the Italians. Ugh, it was very scary. Okay, example 3. Okay, this movie I would never recommend. It's called 47 Meters Down. It was just atrocious. Sorry if anybody's a fan of it. A pair of sisters decides to take a sketchy boat into the ocean and get lowered in a cage to check out the sharks. FYI, I again do not encourage you doing an activity like this or watching the movie. It was pretty lame. But I did watch the entire thing. Big spoiler, if you didn't know, things are going to go wrong and the cage with the sisters will plummet 47 meters down. Get it? That's the title. To the ocean floor. Sharks are, of course, everywhere because it's a movie. And things are looking grim. The sisters drift away. That should be an S. Sorry, the sisters drifted away from their original drop location. If the captain of the boat could see the cage, it would be at an angle of depression, which is probably how these girls are feeling, of 12 degrees. If the boat drops down, an anchored rope, how far will the sister need to travel across the ocean floor in order to reach that rope? Okay, we got a lot going on here. Let me show you what I'm talking about. So we have 2 girls, and they're in some sort of cage. Okay. This looks like they're in prison. They drop to the bottom of the bottom of the ocean floor, wherever the heck they were. Okay, and then here's this sketch boat that decided to say, hey, do you want to pay us like a couple bucks and we'll fling you in a cage and drop you in the water so you can see some fish, which are actually sharks. This boat, we're just going to say here's the eyeball, okay, of the person. We're going to go horizontal this way. And these girls drifted far away, unfortunately. And so this angle is not going to be to scale. Okay, so we're going to say this, okay. And so the angle of depression is 12 degrees. Okay, again, you're going from the horizontal, going down to with your eyeball to look at your location. Okay, now from here, they're dropping down this anchor. Okay, so I don't know how to draw an anchor. Oh, that looks like a fish hook. That reminds me of that movie with that shiny, Moana. Oh my gosh, I love that movie. This looks like a cursive T. I don't know what's going on. Let's say this is a rope. Okay, this is a rope and this is the anchor. See, you don't have to be an artist. Okay, so here's the anchor, there's the rope, and the girls are going to have to walk across. Now, here's what I've already done, is I've done it here at the top of the cage, because this X here, the distance they walk, will be the same down here. It's exactly the same. So we're going to draw our triangle like this. Okay, to find the angle inside, we're going to take 90 and subtract the 12, which is going to give us 78 degrees. And we already know that this is, oh, see, I wrecked it. It's 47 meters down. Okay, so see, I already saw something that is not going to work. So I'm going to try to adjust. So while I'm mumbling to myself, 47 meters is going to be the whole length here. And I just made it touch the top of the tank. So let me redo a little bit here. Okay, so we're going to have them. They are on the ocean floor, okay? And let's go back to blue. Oh, that's not the same blue. Maybe it is. Nope, different. Okay, so we're going to make this go all the way to the bottom. That's what we're going to do. And we're going to make this go along the bottom here. Here's the anchor. And as you can see that I'm changing things up, you're going to be doing the same thing. So before you start plugging away and getting those numbers in, you need to make sure that your setup makes sense. And mine just didn't the way I was drawing that. So I wanted to change it so it did. So the rope length equals, let's see. Tell me I said that. Let's see. If the boat drops down, how far? So we don't know the rope length. This will be fun. Maybe we have to make some. Oh, we do, because it's 47 meters. Oh my gosh. Okay. Because obviously the rope should hit the bottom. Otherwise, these girls are in trouble, which, again, spoiler, they're already in big trouble. Okay. So this is our right angle. We have our angle of depression here. So inside, we're going to have 78 degrees. We have the right angle here, and then again, big surprise, the 12 degrees is down here. Alternate interior angles are congruent. Okay, so our thing that we need to find is this. This is the distance in meters to the rope. Okay, from the girls to the rope. So they're going to basically pretend to run at the bottom of the ocean to get this anchor and get dragged up before the sharks eat them. Or they run out of oxygen. That was a big problem. Never mind. Okay, so let's think about which trig function we could use. We want to find, so we have both of the legs are in play here. So this looks like a tangent situation. So let's go ahead and work with tangent. So tangent, and we can use whichever angle we want. I'm going to do the 78 degrees because that'll give me my x in the numerator, which I like. So tangent of 78 is the opposite, that's x, over the adjacent, and that's 47, x over 47. Okay, we're going to go ahead and solve by multiplying both sides by 47. And then let's go ahead and type this in. And again, we always make sure we're in the right mode. Obviously, if you've been in degrees, you should still be fine. And x is going to be approximately 221.12 meters. Okay, so we will say the sisters need to, I don't want to say run, swim, we'll just say swim about 221.12 meters across the ocean floor to make it to the anchor. Okay. Don't hold your breath for these girls. Okay, rationalizing the denominator. So the goal here, this is just a little bit of, I think, review, but I just wanted to make sure you guys were steady with being able to do this. We do not want to leave a radical in the denominator. So our method for getting rid of this is to multiply by 1. So for the first example, we do not want that radical 2 in the denominator. And some people are, well, I'll just put it in the calculator and I'll get a decimal. That's still not fixing the issue because now you're going to have to round. We want an exact value. So here's what you can do. This is actually radical 2 over itself is 1. So all we've multiplied by is a 1. Okay? So this is a 1, which means we didn't change the value of the number whatsoever. Okay. What is 5 times radical 2? It's 5 radical 2. What's radical 2 times radical 2? That's square root of 4, which is just 2. Now, if you're like, what the heck, how did she do that? 5 over radical 2, we have radical 2 over radical 2. So that, again, that's just 1. 5 radical 2 is in the numerator. This is the square root of 4, 2 times 2. What's the square root of 4? That is 2. Now, some of you are going to get cancel crazy, and you're going to want to cancel those 2's out because it looks so tempting. Don't be tempted to do that, okay? We're not allowed to cancel within and outside of a radical. All right, let's keep rolling. Radical 6 over radical 6, we're really just multiplying by 1. Negative 6 radical 6 over 6. Now we get to do some canceling because we see a 6 over a 6. So this equals negative radical 6. In your calculator, type in this, and you should get exactly the same rounded answer. So we're not changing the value. We're not solving anything. We're just changing what this looks like. Okay, and we're doing this to simplify. Now I see this next one has a 9 and a 12. Well, I know that 3 goes in here 3 times and in here 4 times. So I can actually start simplifying there. And then I still need to rationalize that denominator. So I will get 3 radical 2 over 8. How did I get 8? That's the 4 times 2. This one, I see 2 radicals that have the same factor. This has a factor of 1, 2 goes in here a total of 1 time, and in here a total of 3 times. So this is actually just 7 over radical 3. From here, again, we multiply by our fancy number 1. We do not change the value, we just change what it looks like. 7 radical 3 over 3. This next one we're not so lucky because 3 and 5 don't have any similar factors other than 1. So, oops, I don't want an equal there. I want to actually multiply by radical 5 over radical 5. So this is 4 radical 15 over 5, and we're done. Last one here, we have 2 divided by the square root of 3x. Same idea. We multiply by a fancy number 1. When I do this, on the numerator I get 2 radical 3x, and the denominator 3x. And you're finished. So these are your final simplified answers. Please, please don't say you're solving anything because you're not. You're simplifying. We're just making sure no radicals are left in our final answer in the denominator. Numerator is fine. Okay, that is your video lesson. Thanks for taking good notes. Please make sure you write down your